And then we have the quiz. Okay. Pretty sure my black marker no longer works. It's not with us anymore. So I'm going to use the dark blue and maybe the red. The purple's like light. Like light. I don't know why. I think so. I'll try that one too. There's no rhyme or reason to why I'm having these colors except for they're alive. Okay, so this is 4.5. And what we're doing is exponential growth and decay. Okay, so I had to send y'all a project that Dr. Yoon sent me. Honestly, it's almost 100% like the quiz we're going to do today. So it's like you should be able to do it. In their formula, they use like a capital P. And in my notes, because I believe it goes along with the homework, I use a capital A. So don't get confused if you see it just a different letter. It's still the same thing. Okay. So the way that you're going to find or solve any of these problems for growth or decay, it's going to look like this. We're going to have A equals. Okay, so we have A sub A. I'm sorry, A sub 0. Why did I say that? I don't feel like I'm zoomed in enough. And then we're going to multiply that by E and raise it to the KT power. So A equals A sub 0 E to the KT. That's how you find exponential growth in anything. And the problems we do are like population and stuff, okay? And then you could also use decay. So y'all, there's two different things, right? I'm defining growth and decay. So I'm going to go and write them both. I'm going to tell you what differentiates them. So for growth, this is if k is greater than 0. So a positive number, right? And then for decay, this is going to be if k is less than 0. Does that make sense? If I'm raising, this is my k, this is my k. It's in the exponent. If I raise something to a negative exponent, I'm going to get smaller, right? If I raise something to a positive exponent, anything squared, it's getting exponentially larger. Now you make it, raise it to the 37th power. It's getting even larger, right? So growth is going to be if your k is greater than 0. Decay is going to be if it's less than 0. And y'all, this is where k is our rate. Okay, so I think it's the first few problems. Honestly, I told y'all when I finished this like a week or so ago. So like, I don't really remember how many of these problems there are or anything, but all of these came from your homework directly. What I'm actually going to do is list country 1, country 2, country 3, country 4. Then I'm going to show you their actual growth or decay like formula that's used. And then we're going to determine which one has the greatest growth rate. So I'm just going to kind of show you what it would be asking for there. So y'all literally, country 1. Just do a little semicolon, country 2. Oh, I spelled country wrong. Same thing here. What, Colin? Yeah. What's literally so funny is English is my second love. But I mean, that's a completely different side of your brain. So it's like, I've got to be really committed to it. And I could do really well. I have a very large vernacular. But in math, vocabulary, I know really big words. That's all that means. But yeah, in math, I only think about numbers. Okay, so for country 1, the formula they give us that is used to find either their growth or the decay is A equals, I've got 143.9 times E to the negative 0.009 T. That makes sense? If he's asking you questions about country 1, that's what I use to find those questions. This one, I'm literally just going to show y'all how you can determine which has the greatest growth. The other problems will work more within a problem. For country 2, we have A equals 27.1 e to the 0.022t. And then for country 3, we have A equals 1090.8 e to the 0.014t. And then lastly, A equals 134.4 e to the 0.002t. All this problem does, and honestly, because it is like one of the more simpler problems, I don't see there being but maybe one or two of these, okay? But this problem particular wants to know which country has the greatest growth rate. Well, I already defined the different parts of this formula, and I told you that it's going to be a growth formula if your k is greater than 0, right? It's going to be a decay problem if it's less than 0, meaning it's a negative number. And if you look at country 1, isn't that a negative k? So already, as far as which one has the greatest growth rate, like one's out, process of elimination, right? Like that could be one thing that you could notice. I'm actually going to use my red. What I'm going to do, knowing that it wants to know who has the greatest growth rate, I know that k is my rate, right? So when I look at all of my k's, what I'm going to do is actually turn them into percents and then just evaluate it right there. Whichever one has the largest percent is going to be the one with the largest growth rate. Okay, so it's kind of similar to like those compound problems where you take out a loan at 9%, but when you actually put it into the calculator, you have to scoot your decimal over, right? You got to turn it into a decimal approximation. That's what's been done here to be able to use this formula. So you're just going to kind of go the other way with it to see its actual percentage, and then that way you can see which one's larger. So for this one, I would just take my decimal, I'd move it over 2 times, and I would get a negative 0.9%, right? And then doing it for country 2, I would move my decimal 2 times, and I would get 2.2%. Country 3, what is that? 1.4%. Country 4, I've got 0.2%. Looking here, which one would have the greatest growth rate? Yeah, country 2, because this is the rate, and I know it's growth because it's positive, right? And so that would end up being it right here. You would literally just say that country 2. Country 2 has greatest growth rate. Because it's really just identifying that your K is your growth rate and understanding that a positive K is growth and a negative K is decay. That sounds funny, negative K is decay. I don't see there being a ton of these on here, but hopefully that kind of explains the formula that we're using a little bit more. Our T is usually going to be in time. It could be days, it could be hours, it could be years, it could be whatever it tells you. Like it'll declare what your T means. And then this side right here is going to actually be that's going to be your answer that you solve whenever you do work within these problems. Okay, so let's actually do a problem, okay? I said they're kind of wordy. That's not really too bad, but this one says A equals 435.7 e to the 0.006t. So I guess that would be our first problem on the first page. We have A equals 435.7 e to the 0.006 t. Okay, so this describes population comma A in millions, and then comma years after 2003. I just did comma T. That's my years after 2003, that's my T. My A, so right here, this is going to be the population in millions once I solve the problem. My T is going to be based on the number of years after 2003, okay? So they'll give you information and you plug stuff in. I would solve little problems within problems to get your answer unless you're like perfect at putting everything into your calculator. Could just be really careful doing that. The answer will look right, but it could be really wrong. We have an A, B, and C part, I believe, for this problem. Yes. So for A, it wants to know what is the population in 2003. I'm writing pop, y'all. What is the population in 2003? Question. In like the actual problem where it described everything, it told me that T was the years after 2003, right? How many years are after 2003 if it's asking me about 2003? Like there's none years, right? 2003 is 2003. Like that's my base. That's where I'm starting. And so our T would be 0, right? If it said, what's the population in 2004? Okay, well, my T is the amount of years after 2004. My T would be 1. 2005, 2006, 2000, right? Does that make sense? So if it's actually telling you that your T's like contingent on and based off of the number of years after 2003, then it wants to know the population in 2003, like that's just 0. Then you actually notice a pattern, I know you will, is that if it asks you for this specific, don't want to say this specific year, but if you know that it wants to know like the current population, that's always going to be your T equals 0 because it's current. So what ends up happening is you end up just getting our A sub 0 right here. And if you, I'm going to solve it and show y'all, but then on the quiz, okay, like that's the train of thought that you should have when you answer that. Technically what I just found here was my T. So I'm going to plug everything into this formula, plugging in my T, right? So I have A equals 435.7 times E raised to the 0.006 open 0 close, right? My T 0, I'm plugging in 0. So I recommend, y'all can't see my calculator. I'm going to have to solve some stuff up here though, but I recommend going ahead like, right, like order of operations, like let's work within the exponent and let's evaluate that exponent and then you could do the multiplication. So right now I'm wanting to know what is 0.006 times 0? It's just 0, right? So I'm going to go and rewrite the problem with 0 as my exponent. So 435.7 times E to the 0 power. Y'all, what is everything raised to the 0 power? 1, right? I know it's 1, right? So we have A equals 435.7. That E to the 0 just became 1. And if it's like, I can't remember that fact, that's fine. That's why you have your calculator, right? To like solve the little things here and there. Once you do second division symbol and you get your E and then you hit the caret and then you type in 0, when you hit enter, it'll show you 1, right? So you could do that if you needed to. But do y'all see how this is based off of this year? This is my current population. It's giving me everything I need to project what will the population be in latter years, right? Just continuing on and on and on, because it wants to know right now. That's what ends up making all of this. Technically, it just goes to 1. That ends up just being your population, okay? Because it's like, that's your base year. That's where we started. Okay, so for part B, it actually wants to know what is population in 2020. This amazing year. I'm being facetious. Okay, so if it wants to know what the population is in 2020, that doesn't tell me my T, right? Like you do not put 2020 as your T, right? I'm basing my T off of how it described it, which was T is the years after 2003. Well, if I'm, and this one's like, y'all come on at 17, right? But if it's like weird numbers and you can't just do it in your head, all you have to do is just subtract them from each other. That difference, that's the years since, right? So if it's telling me my T is based off of 2020, and I know that T is the years after 2003, what I get is 17. And all this is saying is that 17, if I added 17 to 2003, I'd get 2020, right? So that's the amount of years after. I don't really like the red that much, but it writes. Okay, so that's my T. Equals 17. Now you're literally going to do like we just did in A, but instead of 0, my T is 17, okay? So I have A equals 435.7 times E raised to the 0.006 open, 17 close. I'm just plugging in my T. Now, again, y'all can't see me, but in my calculator, I'm going to do this multiplication right here within my exponent. I'm going to rewrite the problem. It seems really redundant sometimes, but if you did make a little mistake, like I did in my first class, you could actually go through your steps, and I've skipped a lot, and lots of confusion came from it. If you actually multiply 0.006 times 17, what you get is 0.102. So in the exponent, I have 0.102. Now, again, with your calculator, what I would do, there's another step that I skipped and y'all can't see me. I'm actually have to do it. In my calculator at home when I was doing this, I did second division caret 0.102. You cannot see it. Oh, do you see it? Very bottom. 1.10738.347. It's big, right? Well, instead of actually writing 435.7 times this whole decimal, I know that once I evaluate this, aren't I multiplying it to this? So all I did once I got my answer was times 435.7 equals, and then that's your answer. Okay, there's nothing wrong with writing it. Just told you to write it. It's a long decimal though. So what we get is that our A is equal to, it should tell you what to round it to. In my answer, I round it to the 10th. So I'm assuming that's what it had told me before, because I have 482.486, that 8 tells my 4 to go to 5. And that would be in millions. Does that make sense, y'all? I would just be very wary of entering the whole thing into your calculator. I'll show you how. That's actually what messed me up on this C part. I ended up taking the natural log of like this ugly fraction and then divided it by something, and I did everything in my calculator. So it was fine at home, but then trying to teach it, I went a different route. And this is the part I'm talking about. This is C of this problem. Now the question wants to know, when will population be 506.6 million? So I'm going to start with the same step I did previously, right? Like it gave me some kind of information. If I needed to find like the actual answer, right? Like solving for T and getting 17. Once I knew what I knew, I plugged it in, right? So in this right here, right? So describes the population, A, right? A is my population in millions. This problem asks me, when will my population be 506.6? So that's my A. Okay, so what you do is you do 506.6 equals, and then following the rest of the formula that it gave me, right? It was A equals 435.7 e to the, right? Well, now the only thing is I actually know this A. Now we have times E raised to the 0.006, and then t goes here, right? It didn't tell me to find the population on a certain time that they gave me. It tells me when will this population be this. So it wants to know what year will it be this, right? Like what is my t? Technically just what is my t? Oh, you know what? Just for, so y'all know, can y'all see that? I actually did solve it. I didn't even get to that part of this question because it got so ugly. Okay, so we do t. I told him, I said, y'all watch my 11 a.m. video, it'll be way better. Okay, so now we need to solve this. So the way you solve problems that are written in exponential form is with the logs, right? It's either going to be the common logs or the natural logs. It depends on what your base is. You notice here, I have a base and I have it raised to a power, right? Well, I need only the base and the power. So the fact that there's this coefficient of 435.7 multiplying my e raised to a power, what I want to do is the inverse of multiplication, right? The opposite. And I want to divide both sides by 435.7. Does that make sense? I want to get it to where it's just b to the x, right? What you do to one, why did I make that like an exponent? What you do to one side, you have to do to the other. On that right-hand side, I can clearly see y'all that that's going to cancel, right? Like that's why I did that. That's going to become 1 and then this. But on this left-hand side, we're just going to use our calculator and we're going to type in 506.6 divided by 435.7. It is a very ugly decimal. Unless it says don't round until the end, right? I did round in the previous class and I still got the same answer. So it should be okay. I get 1.162726647, like that's fairly large, right? I'm actually just going to make it 1.16. Yeah, 3. We'll do that. 1.163. So all I did was just divide these two terms right here, and then now I'm working on the rest of the problem. Y'all agree with me that goes away? That's why I did it, right? So I'm glad it went away because I needed that to be gone. So the only thing I have right here is just e to the 0.006t. The goal hasn't changed, right? I'm still trying to figure out when will the population equal what they gave me, which means I'm trying to find my time or the amount of years past 2003. I'm trying to solve for t. Because it's in the exponent and it's in the b to the x form, this is where I use what we've been doing up until now. I know that I have the natural log, which is base e, right? And if I take the natural log base e of e to the x, what does that equal? Is it just x? Yeah. Even if this, if it was a base 10, it would say log 10 of x, right? Is that property? So if you have where it kind of stair steps and it has 3 different things here, what you do is it's just your exponent. So that's 4.3, 4.4, like it's everything we've been doing, right? So I'm going to use this fact, right? I'm going to actually take the natural log, and I'm doing natural log, y'all, right? Because it's base e and this base is e, right? I'm going to take the natural log of this right-hand side so that I can just work within this exponent, but whatever you do to one side, you have to do to the other. So we're actually going to take the natural log of both sides. Okay, so I take the natural log of 1.163 equals the natural log of e to the 0.006t. Writing your base here isn't required. It's not mandatory. It's optional. If it helps you see the property that you're using, that's fine, but you don't have to, okay? So on the left-hand side, I actually noticed that I'm going to have to use my calculator to solve that, but I know that there's still a lot of work to do over here, so I wasn't going to just evaluate this yet. I was going to look over here. I did this so that I could just have it as my exponent. It's like the fact that I added natural log because of my right-hand side, I want to do all of the work that's required on my right-hand side. If you had just taken the natural log of this and then done this, I don't know for sure if your answer would be correct. I'm going to wait until the very, very end to solve for my t. Because it's multiplying with 0.006, what would I do if I'm solving for t? Wouldn't I just divide by 0.006? And then what you do to one side, you have to do to the other, right? Now, the left-hand side, I'm like, okay, I can actually go ahead and enter that into my calculator and I can evaluate it. So what you do is you touch natural log. It already gives you the parenthesis 1.163. Close your parenthesis. If you don't close your parenthesis and you type anything else in, it's going to do order of operations and your answer is not going to be correct. Close it after your 3. And then because this says divided by 0.006, I'm going to do divided by 0.006 and I'm going to hit enter. You should get 25.16714, something big, right? So they actually have us round to the closest year. Because my 10th place is a 1, it's just 25, right? My t is 25. When I evaluated this in my calculator, I got 25. I did approximately, right? Because it is like a decimal. But they did tell me to round to the closest year. So then that's when I knew, okay, my year's going to be 20, not my year's going to be 25. My years after 2003 is 25. So I take this t and the fact that I know that my t is based off of years after 2003. And what I do is I just add 2003 plus the 25 years I found, which is 2028. This is saying that in 2028, with the formula that we had starting at 2003 and all the information they gave us, the population will be 506.6 million. Does that make sense? Yeah? Okay. Okay. Oh, I kind of just defined a couple of things here. In these problems, right, like, you know, talking about growth, talking about population, like that makes sense, right? It's just always growing. There's a few problems, I don't know how many, that talk about carbon dating, right? Because that would also be an example of decay or growth. So if in your homework, if you see, okay, so say it says half of original or half-life. What you do is you take your a sub 0 and you divide it by 2. Just time-wise, I couldn't do so many different problems. And so I just want you to know if you see this. If, say it says like 18% of original, what you do is you actually are going to convert that into a decimal and you're going to multiply it times your a sub 0. Y'all, it could say 23 of the original, whatever, like this is just an example. Half-life though is this. If whatever it tells you here of the original, you would actually multiply it by this decimal. And then everything else after that should follow what we've already done, okay? Kind of quickly, I still want y'all to be able to take your quiz. Okay, so we're gonna do this last example. What sucks is not only can I not do English in my math class, I'm not an artist. And there's a table. But it's okay, because it's not that bad. It's pretty simple. I actually have 2 rows and 3 columns. My first row can be skinny. And I believe the directions on the homework just say complete table. This is actually going to be a growth table. Three columns implies that I just need 2 slashes, right? 1 less than the number you need. For row 1, column 1, I have 2007 population. Well, they actually gave that to me as 18.6. And I don't have this written, but I'm assuming it's in millions. Okay. For row 2, column 2, I have projected, I just wrote PROJ, y'all. Projected 2043 population. They gave me 27.9. What it is that I'm finding is going to be row 3, column 3. And it's going to be my projected growth rate. And very first page, didn't we say that the growth rate, that's our K, right? So what I'm finding is the projected growth rate. I've got the formula. I'm finding K. It's in the exponent. So I'm going to be taking a log of something, right? So that's what I'm finding right here. Oh, that's my K, y'all. I'm finding my K. So using the formula that we know, I wonder if this purple would be better. This blue's right funny. Using what we know, which is A equals A sub 0 E to the KT, right? Again, the little project I sent y'all just like fill it out, bring it to the next class on paper. I think they use P, same thing. So that's what I know. Okay, so they would give me this and we would be finding, right? Like when was the population in 2017? This is what I'm finding. This ended up being what my population was after I solved the equation, right? Well, if they're telling me that the projected 2043 population is 27.9, that goes here. Just like when it said, when will it be 506.6? That was the projected population. They just wanted to know the year. Your 27.9 goes here. Where we begin, where we start, that was my A sub 0. That's why it's a sub 0. Okay. It's like that's your beginning. That's where you're starting. So that's 18.6. Your E is E. It's always just E. Okay. Then it says raise it to the KT power. Okay. So I don't have either of those, right? In a way, you kind of do have your T because I know that this is where I'm starting at 2007 and my projection is for 2043. So when I just find their difference, and that would be the time, right? So 2043 minus 2007, just kidding, comma, 36, thank you. I entered a comma. So in my exponent, what I have is 36 times K. That's just 36K, right, y'all? I don't have to like write it again. My T is 36. What I don't know is my K, which makes sense after I plug everything in because the only thing it told me to find was my projected growth rate, right? That was my K. If you plug stuff in and you've got a few different letters going on, like you know that information, you just might not understand what it is that it's telling you. Okay, so solving this right here, it's literally just like the previous problem. So I've got a coefficient and then I have a base and an exponent. Because this is base E, I know I can use natural log, but I want it as just this form, right? Well, in order to do that, I need to like get rid of or use the inverse to just have my E to the 36K. What I'll do is divide because it's multiplying, right? So that's going to be the inverse of multiplication. What you do to one side, you have to do to the other. And then y'all just use your calculator. 27.9 divided by 1, 8 points. Fat fingers, 27.9 divided by 1.6. It should be like 1. Yeah. Okay, so what I get on the left-hand side is 1.5 equals those canceled. That's why I did it. Okay. Now the only thing I have on the right-hand side is E to the 36K. Now, do you recognize this form? I feel like we've solved a lot. Like if you're up to date on your homework, this is 4.5. So all 4.2, 3, 4, part 2 of part 4 or whatever. I mean, it's like there's been a lot of this. You should be able to recognize this. I'm going to use the natural log to solve it, right? Well, I know I'm going to need to take the natural log of both sides. I don't have to write my base because it's implied that it's base E. Left-hand side, I'm going to wait before I evaluate that because I know I've got stuff going on the right-hand side. What I have going on, y'all, that's a 36, sorry. What I have going on is that I've got natural log base E of E raised to a power. Using that property, you just have that exponent. So I have natural log of 1.5 equals 36K. 36 is being multiplied to K. I'm trying to solve for K. In order to isolate that variable, I need to get rid of the 36 because it's multiplying. You do the inverse, which is division. And what you do to one side, you have to do to the other. Get your calculator, right? Natural log, it already opens up your parenthesis. You do 1.5 close divided by 36 equals. Okay, so I get 0.011262911. I mean, it's fairly large. I rounded to the 4th decimal place. So what I get is 0.011. That 6 tells my 2 to go to 3. Because it's a decimal and it's approximate, I do my little squiggles. That's approximately my K. Y'all, if this was a decay table, my K should be negative, right? And then I just came up here and I wrote 0.0113. It'll tell you what to round to. I assume since I had the homework open when I was doing this, it told me to round to the 4th. You know what I mean? That'd be a pretty large number. Okay. Does that make sense? It's literally the exact same problem, but it looks different because it gives it to you in a table and it doesn't give you all the information. You've got to understand where it goes and why. Okay, so y'all have 7 minutes. It's more than enough to do this, believe me. I just hope y'all can see it. Let me close or delete. Gotta watch this and see if it was good.